can run again any file which you have, or I can give you the file. You can run that particular file if you want, because this session and these are tutorial sessions, so this the hands-on practice also. So if you want to come, anyone who is interested,
maybe you do the SFA first and then I ask whether anybody is volunteering to try,
okay.
instead of repeating what you have done before.
So, so first we revise that the previous lecture. Then I will call upon any one of you. Then you have to do the same thing. Okay, and then we'll start the next lecture. You can come. So this is the first window. Then you open the data. Okay. And okay, you can tell the steps to me. I can do. How to import the data? Go to file, then open, and then select the file where we have you have saved your file. For example, any file, say daily file, and then click on open. And this is the command if you use to import the data by using the command. So this use is the command, use, and the destination of your file. Then how to generate any variable or variable or anything.
Use generate command.
Generate command. So which is the shortcut? Generate command. Next step is enter. What you want? You want a logarithm, na? So simply click on a equal to sign, and then the function log, log of which variable. That you have to select this variable by this arrow, okay, and then click. Now it's right. Now click enter. So now you can check. This is the new variable. Now which can you tell how to check this variable? You. Yes. How to check this variable? The variable there is a list of variables with values. Click on statistics. No. Anyone else? How to check the complete data? Where we have to click data editor. Sorry, this one. Data editor. When you click on data editor, you get the list of all the variables. Or a new variable which you have recently generated. So you can see this is the variable that you have generated. Okay. So this is a data editor. You can check all the variables with their values and new variables. Okay. And then simply click on this cross button. You will return to the Stata. Okay. Okay. Another thing. How to get the summary of the all variables? There is a command. There is a command sum. Okay. And then
select.
and then click OK. This
Go
enter.
to and then select the.
No, you can also. यहाँ ठीक था आपका वैसे. You can click enter also. You will get a summary of all the variables. Okay. For example, we have 10 variables, so you can get summary statistics for all the variables. But if you want to find the summary of selected variables, then you have to enter the selected variables only. Then which is the command? That is sum space and then simply select the variables for which you want to get the summary. For example, ly, l, labor, feed, cattle, and then simply click on enter. Okay. And the second way of finding the summary is go to statistics, then
Summary table.
okay, and then okay, again summary statistics. Then
Select the variables.
for which you want to get the summary. So select, simply click on this, or simply click on OK. You will get the same result. That is a summary. Okay. And the second, one more thing we have done, that is a regression. So command was a regress. R-E-G-R-E-S-S. Regress. Regress, and the second step is to list the variables. Okay. First you have to enter the dependent variable followed by independent variables. So for example, your independent say your dependent variable is this one. Then you have to enter independent variables. First dependent variable, then independent variable. So this is independent variable, this, or this. And then simply click on enter. You will get the regression analysis. Okay. And this is the multiple regression. Why multiple regression? Because it has more than two independent variables. Okay. This already we have done. And the second way of finding the regression was go to statistics, then linear models, and then linear regression. Okay. And the first window is this arrow. Select your dependent variable, then the list of independent variables. Simply you can select the independent variables and then click on OK. You will get the same result. Okay. So यहाँ तक अगर कोई डाउट है तो मुझे बताओ पहले आप. If you have any doubt, okay. This is okay now. So next we will today we will discuss about the technical efficiency. See, is of two types. That is technical efficiency is of two types. One is output oriented, another is input oriented. Okay. So in this lecture we will discuss about the technical efficiency. In technical efficiency we need the production data only. There is no need of price data. But in case of allocative efficiency, you have to allocate the inputs according to the prices. So price data is a must in case of allocative efficiency. And then economical efficiency, you can simply multiply them, you will get the economic efficiency. Okay? Simply multiply the technical efficiency and allocative efficiency, you will get economic efficiency. Okay? So, for example, this is the dose of fertilizer and this is say yield. Okay? So, and these are the farmers. At this dose of fertilizer, farmer B produce 60 tons of any, for example, say wheat. Okay? And this is another farmer, say it produce this much of wheat and using this much of fertilizer input. And similarly, these are the all the farmers. So this is the frontier model. Frontier model is the okay. What is the difference between linear regression and frontier model? You can see here only the difference between frontier and linear model. Linear model, yes.
Frontier is the maximum one.
Yes. Frontier model gives the maximum output based on inputs. Okay? And linear regression gives the estimated value, average value based on all the observations. So this is the frontier model which gives the maximum output based on these doses of fertilizers. And this these are the main points which we will discuss. For example, okay. So this amount is this one 60 tons at 800 kg of fertilizer. So this is the production by using this much of fertilizer, and now this is the production at this is the production at this much of fertilizer, and this is the same production. Same fertilizer dose, and the production is 100 tons. Means there is some inefficiency of means farmer C having some inefficiency. So how to measure it? Amount of inefficiency we have to measure. Means for the same dose, farmer C produce 60 tons, and the same fertilizer dose farmer A produce 100 tons. Okay, input is same but output is different. So this type of inefficiency is called technical inefficiency and output oriented inefficiency. Output oriented inefficiency means when we fix the amount of input and we have to maximize the output. Okay, and this is the amount of inefficiency. based on this this dose of fertilizer. Okay. And in case of input oriented efficiency, so this much is the say we have fixed this value. So this is the production, and these are the doses. If 100 kg is the fertilizer, then this is the production, and at 800 kg the same production is there. Means there is also inefficiency, but in terms of input. So this inefficiency is called input oriented inefficiency. Okay, clear? So
repeat input.
technical inefficiency is of two types. When we fix the input and we'll get the different outputs, or you can say we maximize the output. Okay, so this type of inefficiency is called output oriented inefficiency. Okay, and when in case of input, if we fix our output, okay, and try to reduce the input, so you can see that at 100 kg of doses you will get 60 tons, and 800 kg of doses farmer C is also getting 60 tons. So there is a gap. Output is input is same. No, sorry, output is same, but input is different. So in case of input oriented inefficiency, you have to fix. You have to minimize the inputs. Okay, but in case of output oriented, you have to maximize the output based on inputs. It is clear to you? So
Can you go to the SCADA code?
yes, sir.
Can you show them that, because you have only 1 hour,
Sir,
right?
sir, we have slideshow
Okay,
on data. Okay, so output oriented, by how much can output quantities be proportionally expanded without altering the input quantities used? That is output oriented inefficiency. Then input oriented, by how much can input quantities be proportionally reduced without changing the output quantities produced? Okay, so how to derive technical efficiency? So there are two methods. One is parametric method, that is frontier analysis, and the second is non-parametric method, that is data envelope analysis. So there are two methods. One is parametric, other is non-parametric. Why parametric and why non-parametric? So in parametric we have some distribution. For example, normal distribution, truncated normal distribution, half normal distribution, exponential distribution. Okay, then how to decide which distribution is used? The next question is how to decide which distribution is used to find out the inefficiency. So we have to check the residuals. Residuals means error term. You have to check the distribution of error terms. If your error term is normally distributed, then you have to use a normal distribution. If your error term means residuals, for example, your residuals are of exponential type, then you have to use exponential distribution. Okay, so this frontier analysis is the parametric approach, and this DEA is the non-parametric approach. Okay, and we all know that the parametric approach is more efficient as compared to the non-parametric, because we have some type of distribution. Okay, but in case of non-parametric, we do not have any distribution. Okay, we don't know about the population, which type of population is there, which type of observations are there. We don't have any idea. But in case of parametric, we have some idea about the population, whether it is normal or exponential, truncated normal. Okay. So this is the parametric and non-parametric. There are two methods, and these are the softwares on which we can analyze the frontier model. This is Stata. We will use them. We will use it, and this R software, and this is the DAP software. Okay, so these are the software which is used to analyze the DEA model. DEA means data envelope analysis. Okay, and then because our focus is on the technical inefficiency, and which is output oriented inefficiency, so that's why we are using frontier analysis only. Okay, so frontier analysis is maybe used to find out the output oriented inefficiency, and in case of input oriented efficiency you can also use the frontier analysis, and we are focusing on this one only. Okay, these are the three distributions. Okay, this half normal distribution means if you have any idea about the normal distribution, then you can easily check that which so for example, this is say graph of say normal distribution. You know na? Normal distribution is L shape and then all that.
Yes, sir.
And half normal means like this part. If your residuals of the model behaves like this, only this type of distribution, how to check it? Simply draw the histogram. You will get the idea. Okay. So if your residuals are of type this one, means half of the normal. This is not there. Half of the normal is there only. Then you have to use this one, half normal distribution. Then exponential means the graph should like this one. Means then in exponentially decreasing order, or it may be increasing exponentially. Then you have to use exponential distribution. Okay, and truncating normal means if we break the normal distribution from here, this rest of this distribution is called truncated normal. Okay, so then we have to use a truncated normal distribution. So we have three distributions. One is half normal, other is exponential, and the third one is truncated normal distribution. In case of frontier analysis, to find out the output oriented technical efficiency. Okay. So now this is the functional form of the stochastic frontier analysis. You can easily see that this is the output. Okay, and these are the inputs. It may be labor, it may be any type of capital. This T is the time variable. Okay, and this theta is the coefficient of the input variable. So you can say elasticity of the output variable. Okay, and this term, this V, is the random error term, or you can say residuals, or you can say white noise. Okay, and this mu is the inefficiency term. Okay, this is the inefficiency term, and this term is always greater than equal to 0. And say this term follows some another distribution as sir said in the lecture. So this is the technical inefficiency term, mu. Okay, if your mu is statistically insignificant, or you can say statistically zero, that means your stochastic model becomes your stochastic frontier model becomes a simple production function model. If there is no inefficiency term, then your stochastic frontier model becomes a simple production function model. Okay, it is clear that?
Yes.
So next, how to run the frontier model, stochastic frontier model in Stata. These are the codes. Okay, if you want to note down, you can note down. So this means the frontier. This is the main command. Okay, and Ly means dependent variable. This is these are the independent variables. This is the simple frontier model. There are other frontier models also, in which we will use the say, you can say that we will use the regression of this technical inefficiency term also. But this is the simple. We will show you in the little lectures that how to use that mu as a function of some other variable. Okay, so this is the frontier, and this is the command to predict the inefficiency. Okay, and this is the inefficiency term. So simply write predict, and you can write anything here. Means this is the variable name. You can give any name to the variable, and this mu is the technical inefficiency. Okay, and this is used to find out the technical efficiency. Again, the same code predict. You will get a technical efficiency. There are two things. One is inefficiency, other is efficiency. Means which farmer, how much is the efficient, which farmer is inefficient. So you can get efficiency as well as inefficiency of the particular farmer. And this isegen, is the command to use the frequency groups. Frequency groups of which efficiency. At for example, we have to generate the frequency group, for example 0 to 3, means up to 0. How many farmers are there who have 0 efficiency? Okay, then how many farmers are there having 0 to 0.3 efficiency, and how many farmers are there having 0.3 to 0.6, or you can say up to 60% efficiency, and this one is the 100% efficiency. Means how many farmers are there in your data who have 100% efficient, 100% of efficiency. Okay, so this is the command. This is the again the subsequent command tab for tabulation of this group, and then summary, SUM, summary of efficiency. You will get the summary, that mean, standard deviation, and average. You have that much of efficiency. Okay, so now these are the steps. I already told that there are two steps. One is by clicking on the statistics button, other is by typing the commands. So this is the linear. First click on statistics, then linear models. You will get frontier models. Okay. Yesterday someone asked, I think, why we use this stata. So that's why we are using stata. There is a command in stata for frontier models, but in case of SPSS there is no command for frontier models. Okay, that's why we are using stata. So this is click on statistics, then linear, and then frontier models. You will get this window. Okay, then you have to select the dependent variable, independent variables, and you have to select the distribution. How to select the distribution? We have already told that you have to find the residuals. Okay, and then plot the residuals, or you can say make a histogram of the residuals, and then check whether the residuals are having this type of distribution, or this type of, or this type of distribution. Okay, so first you have to run simple regression, then find the residuals, and then simply draw the graph, and then check whether which of the distribution is followed by the residuals. Okay, then click on OK. You will get this type of window. Here you can check. Here you can check this. This is the stochastic frontier model, half normal model. You can check here stochastic frontier model. After four iterations, you will get the results. And this is the overall significance of the model. You can check here world statistics. You can check here p value is the less than 0.05, means 0.000. So this overall model is significant. Then come to the variable wise significant of the model. So first is the land, then this one, and this is the U term. Is it visible?
No, sir.
Now you can check that. Okay. This one is the U, or this one is the V. In the previous model, we have two terms, U and V. U is the mu. Mu is the inefficiency term, and V is the random error. You can say white noise. Right? So this is the coefficient of this sigma mu. You can check this is 0.20 and this is 0.06. So how to check there is an inefficiency in the model or not? So simply check this value. If this value is greater than this value, means V minus U, you will get a negative value.
Yes, sir.
That means there is a inefficiency. Okay? Clear enough?
Yes, sir.
And this this lambda is the ratio of the variations. This lambda is the ratio of variance of inefficiency term to the total variance. Total means variance due to residuals and due to inefficiency term, some of them, and then the inefficiency variance is divided by total, you will get the lambda value. Okay. So now how to predict the efficiency? So this is the command predict efficiency, and then TE means technical efficiency. Okay. And this is the frequency table. Now you can check, this is the frequency group and this is the efficiency. This is the efficiency and this is the group. We have already, there are 4 cuts now at 0, at 0.3, and 0.6 and 0.9. So this efficiency comes in this type of group. Okay. This is the technical efficiency, the list of technical efficiency, and each efficiency has some group because we have already divided in 4 groups. And this is the table of this frequency group. Okay. So these are the frequencies up to 0.3. There are 2 farmers having less than 0.3 efficiency, and there are 127 farmers having less than 0.6 efficiency, and this is 0.967, and total are 196. Okay. So these are the commands. So you can check the table of the efficiency, and you can divide them into groups also. And this is the summary statistics of the efficiency. You will get SUM command for the variable that you have already given, and this is the summary statistics of this efficiency term. Means on an average we have the mean of the efficiency is 0.85, means 80%. Means on an average the efficiency is of all the farmers, out of 190 farmers, mean efficiency means 80% of the farmers are efficient. Okay. And this is the standard deviation. This is the minimum value having minimum efficiency, and this is the maximum value. Okay. So this is how we can find the efficiency. Okay. And this is the another code for inefficiency. This is the SF command, SF cross for cross sectional data. Here you can use that inefficiency, the region of inefficiency which cause the inefficiency term. Okay. So this is the command SF cross. Simply you can write the dependent variable, then independent variables, and this is the model. These are the models. Model is say BC. BC is this model. What is Kohli model in 1995, and that TFE is the two fixed effect model, and this for distribution. The TN distribution. TN means truncated normal, or you can write it here half normal, HN, half normal. Accordingly, if your residuals are following truncated normal, then you have to write TN. If your residuals following say exponential, then you have to write exponential. So, and this is the orientation. ORT is the orientation. Orientation is a output oriented, and this E-mean. E-mean is the command to check the region of inefficiency. Which variable you have to check which variable is responsible for the inefficiency. Okay, so you can write here any variable that you want to check whether it is significantly impact on the inefficiency or not. And this is the command predict, that variable name, that is JLMS, means John Rowe, that is to predict the technical efficiency. Okay, and this is again some command to summarize the technical efficiency. So how to use this command? So simply write the command, okay, then dependent variable, and then independent variable, then model. Which model you want to check? You can use BC model, you can use a TFE model. There are some other models also. And this is the distribution, dist, and this ORT is the orientation, and E-mean is the command to find out the expected value of means, or you can say the conditional mean. Okay. And after so many iterations, there are 100 iterations, you will get the result. There are 100 iterations, you will get the result. So overall significance, this is the overall significance of the model, and then you have to check this individual, there is impact on output or not, and this is the important thing. This is your mu. Mu means technical inefficiency term, and this is the computer, or you can say any variable that you want to check. This means minus 2.95 means this expenditure on IT having negative impact on inefficiency. This means this variable having negative impact on inefficiency, or you can say this computer IT having a positive impact on efficiency. Okay. So this is the stochastic frontier model using E-mean command, or SF cross means SF means stochastic frontier, cross means for cross-sectional data. Okay, and this is the command to predict the technical efficiency, and this is the to get the summary of the technical efficiency. So this is the mean of the technical efficiency, and this is the minimum value, and this is the maximum value. Okay, and this BCTE is the technical efficiency term. You can give any name. Okay, this is the technical efficiency. This is the BC. You can check here from the editor button. You can check the efficiency of the model, the list of the model. Okay. So this is all about the technical efficiency using stochastic frontier model, and there are two commands. One is simply frontier command, and other is SF cross for cross-sectional data. In next lecture we will discuss about the panel data regression. So if you have any doubt regarding this, you can ask. You can run a file also. So simply open this data, and then type the command SF cross, then dependent variable followed by independent variable. type of models, BC and TFE. BC means Barty's and Polish model, okay, and TFE is a two fixed effect model. So you can use say BC, then dist. Dist command is used to distribution. So say truncated normal distribution we are using, okay. The next is a ORT means a orientation. Orientation is a because we are interested in finding the output oriented inefficiency. So you have to use a O for output oriented inefficiency. Then next is one of the important command, E-mean command. E-M-E-A-N. So E-mean command is used to check the effect of any variable on the inefficiency. So we have to select that particular variable. Now we are selecting this comp variable, okay, and then click on enter. After many iterations you will get result. So there are around 100 iterations. You have to first you have to check the overall significance of the model. So now you can check the overall significance of the model from this p-value. This p-value is significant. So your model is significant. Overall model is significant. Now this is the frontier model. This is the frontier model, stochastic frontier model. You can check each and every variable. This first variable is not significant as the p-value is greater than 0.05. Okay, and then second variable is again not significant. Third variable is not significant. This is the cattle's number of cows. If you increase the number of cows, then the production of milk will increase. So, and this is the constant variable, and this mu is the inefficiency term. So inefficiency, and this is the variable. So this means this variable having negative impact on inefficiency term, not efficiency, on inefficiency. We have regressed the inefficiency term with this variable. For example, in any industry, there is a variable, say experience. If we increase the experience, if we hire the experienced people, say, then production will increase. So if the experience is low, then the efficiency is also low. So experience having positive impact on the efficiency. So you have to check that particular variable. Is there any impact of that variable on inefficiency? It will increase the inefficiency or not? You have to check first. You have to check if there is any variable which is a positive impact, which is having positive impact on inefficiency term. Okay, then you have to increase that particular variable. Okay. So now how to get the inefficiency, or you can say efficiency? So simply write the predict command, predict variable name that you want, say efficiency. Okay.
Do you have any illustration for half normal case?
Yes sir. Yes sir.
So I mean, can you quickly go over to the half
Half
normal
normal.
case?
Yes sir. Yes sir.
Yeah.
So this is the command, the predict command. And if you want to find the efficiencies, so simply write the predict command, then variable name that you want to give that particular value, and JLMS, Jordan, John Roe, okay, given by John Roe, and click OK. You will get the variable EFF on the right side. This is the efficiency term. Now you can write on editor window, you will get the efficiency of each and every farmer. This is the efficiency. Okay? This is the efficiency. Now, how to get the summary of this efficiency? So simply SUM, you will get the summary of the efficiency. So these are the number of observations, means the number of farmers, and this is the average efficiency, that is 93% of the farmers are efficient in producing the milk, and this is the minimum value of the efficiency, and this is the maximum value of the efficiency. So sir said for half normal, sir.
Yeah. I mean, if you have that example,
No, sir, example I don't know.
or you don't have that example
No, no,
of
no.
okay.
I have run on this file only, sir.
Oh, okay, okay. Then it will take time. So, anyway.
Okay. So, if there any doubt, you can ask, or if you want to run the code, you can come and you can run the code for stochastic frontier using cross-sectional data. So anyone who want to come, because it's a hands-on session, so you have to come.
Okay, Manisha, you want to run some file? You can just try.
So you don't have any data on your own, right? Nobody has any data? That's kind of strange. I mean, you are I know some of you are not that stage yet, but I was hoping that there are people who are working on some projects.
So please help her. This is the first step, how to
Choose the file.
enter the data or how to import the data. Then
So Manisha, you can sit down with him, then you can just select
click
the
and
files.
open. Don't save. No problem. Okay. So this is the new data. This is the new data, na? So show the data. How to check the data? Data
editor.
editor. So click on data editor. You will get the list of all the variables with the values. Okay. Then
So direct data field of this.
okay. There are two or three options. You can import from Excel also, or you can directly type in the data. Just cross it. Okay. Now,
Go to
what do you
statistics.
want? Summary?
Yes, sir.
Okay. So this is the command for summary. These are the steps to get the summary.
Summary descriptive statistics.
Okay. Okay.
Summary statistics.
Summary statistics. Then
Choose
these
the
are the variables.
variable
Or you can select the variable from here.
dependent.
So click on this one.
Okay. So already clicked.
Okay.
Then okay.
So you will get the summary of all the
All
variables
the
that you have selected. Okay, and then next is a
regression.
regression. So which is the command for regression?
Linear
What
model
are the
and
steps?
related.
What are the steps? Go to
Linear regression.
and then linear regression.
Linear regression. Choose the dependent variable first.
Okay,
And
you will get the this type of
result
result.
of the
Okay, and if next the frontier model. How to run the frontier model? Stochastic frontier model. Okay, using SF command, SF close command. So first write SF cross, then space, variable names. First your dependent variable followed by independent variable. Click on this arrow. Click on this arrow. First go to dependent variable, then click on arrow. Followed by independent variables. Okay. The next is a
comma.
com-
कॉम तो बाद में मॉडल
then comma,
कोमा मॉडल
then model. Which type of model you want? BC or TFE?
Yes,
You
sir.
can write
ब्रैकेट्स
BC,
ब्रैकेट्स
with
बीसी
parenthesis. Small BC.
स्पेस दे दिया शायद बीच में स्पेस कम कर दो
Then
डिस्ट
space.
डिस्ट
Okay, distribution for disk. DIST, dist. You will parenthesis name of the distribution. That is say truncated normal
TN
TN.
without space
Okay, just for experiment, why don't you put HN and see what happens?
You can put half normal also. HN. Then again
oriented
ORT, orientation. Put ORT, give it bracket. Output oriented, na?
yes sir output
So put O.
No, there's no space.
Space.
there is no space
Yeah.
and
Okay. And then E-mean.
E-mean.
E-mean
So
command.
now there's no E mean, remember, E mean refers to truncated normal, okay? So if you have a half normal, then there is no E mean, because there is no mu. So this is the reason why I was asking to change, because it might not work, because it might be looking for E mean. So let's drop that E mean part, okay? So let's see what happens.
Click on enter.
And that's the end of it. See? So now again, it looks like it's turning because you ignore two things. First, the truncated normal, and since there is truncated normal is eliminated, you have to eliminate E mean also. If you put E mean, there is contradiction, right? Because you want half normal doesn't have mean. So that's kind of the, okay, so now you get the results. See that now these results are making sense. I didn't make any comment on that. Should I go up there just to, or this is fine, right? I'm talking to you. You can record my voice, right? Okay. So, no, I mean, it's not important for me, but again important for recording. Okay, so what is happening, just look at the coefficient. So, no, this is, okay. So if you're looking at this land, that's a positive, that should be the case. It was negative before. So that was not, that's counterintuitive. Land cannot have a negative effect on output, right? So this is elasticity. That means if you increase land by 1%, your output is going to increase by 0.03%. Okay? And look at the second one, labor. That's also positive. That makes sense. Okay? And then again, feed, positive, cattle, positive. Right? So these are all positive. And if you look at the properties of production function, you know that the marginal effects or the elasticities should all be positive, and that's what is happening in here. Right? Whereas if you look at the previous model, first 3 or 4 of the coefficients were negative and insignificant. Negative doesn't make any sense economically, and then of course they were also not significant, right? But again, here land is not significant, but we always say that well, statistical significance is a guide, it's not mandatory. You cannot say that land is not important. How can you produce something, or even this is a cattle farming or dairy farming, you still need land, right? Cattle are not going to be grazing in the heaven, right, or in the sky. You need land. Right? So even though it's not significant, you need to include it. Okay. And then again, so all the coefficients are positive, which makes sense. And then U sigma, which is basically, remember it's a half normal, so there is no determinant in this model. Okay. I think you can put determinant also, but I am not sure about it. I might show it later on how to put determinants in a half normal. Okay. Okay. So the next thing is that we look at U sigma. That means sigma squared U and sigma squared V. Now the way these are modeled, remember sigma squared U has to be positive, sigma squared V has to be positive. This is a negative number. So what is happening? The way the program is written, that it is assumed an exponential function. So it's not directly estimating sigma squared U, but sigma squared V. It's estimating log of that. So in order to get sigma squared U and sigma squared V, you have to take exponential of this negative number, which is what is happening in the next line. What is that? Oh, okay, I'm putting the wrong one. Okay, see that? So sigma U is basically estimate of sigma squared U, and this is sigma squared V. These are positive. If you take exponential of this and this, you are going to get these two numbers. And then again, you can get a p-value or the statistical significance. If you look at the p-value in here, they're all in very, very small, almost zero, right? So these are significant, meaning there is an efficiency. Okay. And then again, you can do the other thing, that you can do a prediction command, exactly the same thing. You can take over. You can just say predict. You type predict, and then I think the same command will work. Predict, and then what did you do?
Space, variable name, say efficiency.
You just do any EFF. Yeah.
Comma, GLMS.
Remember, GLMS is estimating U. Okay.
You can click on editor.
And then again, instead of going to the editor, let's just do something in here. So again, go down in here. That what you are typing. Don't go up. Okay. Go down to that typing part where and then you just do a sum, and then you do efficiency. Okay, return. Yeah? So again, I don't like to go to the data part and again look at the use one, right?
Yes,
so
sir.
you need a summary statistics. See that one, you get the mean, you get the minimum, you get the maximum, you get the standard deviation, right? And again, you can do a histogram. So again, you can just say, what is the command for histogram? So type hist, H-I-S-T, and then efficiency. Okay, see that? You you don't need to go to the data. I don't like to go to the data part and see those things, because what do I get by looking at 1,000 numbers? Nothing, right? Look, you get the histogram. And this is supposed to be the case. Look, 0.5, this is the lowest level, and then the highest level is close to 1. So you see that the distribution of efficiency, right? And then again, you can do a histogram for inefficiency. You can do anything you want, right? Everything is, this is a statistical a package. You can do all sorts of things. I mean, if you want to play with different ways of presenting the results, you're free to do so. Right? You can get the summary statistics by looking at the mean, median, mode, and things like that, or you can just do a histogram, and you can do a fancy plot. So again, let me just, inefficiency we didn't define it, so again, you don't be finding it. So again, if you want to do it, then you have to do a predict, and then use inefficiency, and then GLMS. Yeah, instead of writing that long name, I use just okay. And then again, you can just say sum. I think we should stop this. And then again, like you can do the histogram also.
Simply enter. This
Yeah.
is the summary of inefficiency.
Okay. And again, you can do anything you want to. So you see that well, it's really, the first thing is that well, to estimate the model, and then once the estimation is done, it's everything is inside the computer spread. And then you can call any of those things that you want to do. And we're basically, since the focus is on efficiency or inefficiency, you can do everything related to those things. Right? So at least now you know how to do this half normal, truncated normal, and again you can just do exponential also. Okay. If you don't remember, all you do is that again do a search. Okay, that what is the code for putting exponential? I mean maybe it's E, but I'm not 100% sure.
E expression.
Yeah. Okay. So let's just stop it there. Right?
This is important, U. U is important. If you don't write U, you will not get the inefficiency.
So that's why the command is important. You have to, just like your name. If I want to call you by Manisha, then you are not going to respond because you are not Manisha, right? So this is the problem. That means you have to give the command exactly the way the computer can understand. Meaning the computer knows the name, but if you call it by false name, it won't respond. It will come up with an error message. Okay?
These commands are important, predict and U. And this is the variable name. You can give anything.
Yeah, that one is
Okay. These are important. So thank you.
Thank you so much, sir. Your deep understanding and clear explanations make this complex concepts very easy for us to grasp. And I hope all our participants are comfortable and understand all these things and will use in their future also. So I would like to request all of you for a group photo outside with our two experts with us. And after that we will join lunch. And from 2 p.m. we will gather again here for the next lecture. Thank you so much.